Good morning, everyone. In last lecture, we have studied Fourier integral formula and Fourier sine and cosine integral formulas. Depend on that, um, we have just seen the this example. These are some formulas: Fourier cosine integral, Fourier sine integral, and these are some notes. Depend on this, the integrations we are going to use in the examples. Okay, this integration e raised to ax sine bx, and this is the integration e raised to ax cos bx. These are the well-known formulas, and we know e raised to minus infinity is 0. Frequently, we are going to use these formulas. We have just seen in earlier lecture. This is the question using the Fourier integral representation. We have to show that these three integration values are this. Okay, now we have already done this first example. Now let us see the second example. In first example, sine omega x, in this integration omega is there, and except omega, x is there present in the sine function. Okay, that's why we have to use here sine integral formula, and for using that formula we have just prove this number one example. Okay, now let us see number second one, that is here in the integration cos omega x is there. That's why we have to use in Fourier cosine integral formula here. Okay. Now Fourier cosine integral formula is given by fx is equal to integration 0 to infinity a lambda cos lambda x d lambda. Remember, in any formula, whatever the variable present here in the function, that the integral should be with respect to that variable. Here lambda, here must be lambda. Okay, now fx is equal to integration 0 to infinity a lambda cos lambda x dA lambda. It is the Fourier cosine integral formula where a lambda is given by 2 upon pi integration 0 to infinity fx cos lambda x, here obviously dx. Okay, now here we have to put fx value here like earlier example. What is the function value? If you compare this integration with this integration, this is the LHS side of this integration. Okay, that's why RHS side must be the function, our function. Likewise here also, if you compare this integration cosine integration with this integration, okay, this integration here in this integration standard integration formula lambda is there, while in this integration omega is there. That is the only difference, because they are dummy variables. We can change them at any time in the example as per our convenience. And if you compare these two, the RHS side must be the function value. Okay, that's why we have to put function value as pi by 2 e raised to minus x in this example, and next example pi by 2 as a function in the this integration. Now let us see here, the integration is 0 to infinity fx value we have to put pi by 2 e raised to minus x cos lambda x dx. Okay, pi by 2, this 2 pi by get cancel, integration 0 to infinity e raised to minus x cos lambda x dx. Now we are going to use the formula here, e raised to x cos bx dx. What is a here? What is a? In this example, a is minus 1 and cos lambda x, integration with respect to x, lambda is our b value. Therefore, using this formula here, okay, you get e raised to minus x upon 1 plus minus 1 square is plus 1 plus lambda square into bracket a, that is minus 1 cos lambda x, plus for cos plus is there b, that is lambda sine lambda x. Angle is same whatever it is, cos or sine, but just a value is minus 1, b value is lambda. Just replace a by b here and cos by sine here. That is only terms in the formula. Now here put upper limit first, e raised to in x e raised to minus infinity becomes 0, upper limit becomes 0 into anything is 0, minus lower limit we have to put 0, e raised to 0 is 1 upon 1 plus lambda square into bracket cos 0 is 1 minus 1 is there plus sine 0 is 0, no need to write 0, bracket complete. Answer is minus minus plus 1 upon 1 plus lambda square is the answer for a lambda. Now put this value in our original formula, Fourier cosine integral formula. We get function value fx is equal to integration 0 to infinity a lambda, that is 1 upon 1 plus lambda square into cos lambda x d lambda. Okay. Now function value is, we already put function values, pi by 2 e raised to minus x is equal to integration 0 to infinity cos lambda x upon 1 plus lambda square d lambda. Now in our original example, omega is there variable, that's why we use here dummy variable. Instead of lambda, replace everywhere omega. We get integration 0 to infinity cos omega x upon 1 plus omega square d omega is equal to this answer. Okay. Now let's see the third example. Our third integration consists both sine and cos. That's why ultimately the question arises that which Fourier sine or cosine integral we have to use here. See, here sine omega is there and integration is with respect to omega. But apart from omega, which variable is there? X. And it is present in the cos, that's why we have to use here Fourier cosine integral formula. Okay. Now Fourier cosine integral is given by fx is equal to, formula is integration 0 to infinity, same formula here, a lambda cos lambda x d lambda, call that equation number 1, where a lambda is, this is a formula, 2 upon pi fx 0 to infinity fx cos lambda x dx. Now put the value of fx is the function given in the example on the RHS side of the integration, pi by 2 only. And but this in this third example, integration's limit or x value varies from 0 to 1 only. Okay, that is the only thing we have to make change in integration. 2 upon pi fx value is pi by 2 in interval 0 to 1, where our integration is 0 to infinity, and suppose 1 is there in the function, 0 to 1, in between 0 to 1 function value is pi by 2, which is given in the example, but from 1 to infinity obviously it is becomes 0. That's why this integration split into 2, 0 to 1 and 1 to infinity. In 0 to 1 function value is pi by 2, which is given in the example, and from 1 to infinity the value becomes 0. Okay, this integration becomes 0, and this integration pi by 2 to 2 pi upon pi gets cancelled. Cos integration is sine lambda x upon angle derivative divide, that is lambda, integration from 0 to 1. Now put upper limit in x, sine lambda upon lambda becomes upper limit, minus lower limit it becomes 0. Answer is sine lambda upon lambda. Put this value in our function cosine integral formula, we get from 1 we get pi by 2, that is function value here. Fx is equal to our function value, that is pi by 2. Integration 0 to infinity, sine lambda upon lambda is a lambda value, cos lambda x d lambda. Okay. Now put again dummy variable lambda is equal to omega, because omega is present in the example. That's why 0 to infinity sine omega cos omega x upon omega d omega is equal to pi by 2, where x lies between 0 to 1. Okay. Now consider next example. Find Fourier sine and cosine integral representation of the following function. This is a straightforward question where function is the given in the form of interval, where function is fx is equal to cos x in the interval 0 to pi by 2, and it is 0 for x greater than pi by 2, means pi by 2 to infinity. Now we have to calculate Fourier sine and cosine, both integral representation of the function. Now let us first consider cosine. Fourier cosine integral is given by, this is the formula, fx is equal to 0 to infinity a lambda cos lambda x d lambda, where a lambda is 2 upon pi integration 0 to infinity fx cos lambda x dx. Now put the value of f of x. Function, our integration is integration with respect to the limits are 0 to infinity, but function is given in the form of interval. It's split into two intervals, 0 to pi by 2. Suppose this is 0, this is infinity, this is pi by 2 point. 0 to pi by 2 function value is cos x, and pi by 2 greater than pi by 2 means pi by 2 to infinity function value is 0. That's why this integration split into two, 0 to pi by 2 and pi by 2 to infinity, where pi by 2 infinity becomes 0. Don't need to write this integration, and fx value in this interval is cos x and cos lambda x dx as it is. Okay, now this becomes 0, 2 pi by 4 integration 0 to pi by 2 cos x cos lambda x dx. Now to solve this integration we have to use one formula, cos a cos b formula. What is cos a cos b formula? Cos a cos b formula is half integration bracket cos a plus b plus cos a minus b. Okay, this is the well-known formula. Use this formula here. What do we get? What is a value? X. And what is b value? Lambda x. Okay, use this formula here. What do we get? Two upon pi as it is, half cos a plus b plus cos a minus b dx. You have to write the formula, whatever the property you are going to use in the example, you have to write as the reason of this step. Okay, this is the formula. Okay, now take half outside and cancel with this 2. We get 1 upon pi, 0 to pi, 2 pi by 2 cos of, just take x common from the bracket, we get angle 1 plus pi lambda into x plus cos of 1 minus lambda into x dx. Okay, now what is the integration of cos? Sine. Integration of cos is sine and integration of sine is minus cos. Now cos integration is sine, rest of the terms as it is, 1 plus lambda into x upon angle derivative divide, that is 1 plus lambda, plus cos integration is sine 1 minus lambda into x upon 1 minus lambda as it is, that is the derivative of this angle. Limits as it is 0 to pi by 2. Now put the upper limit first in x, variable is x, that's why put upper limit pi by 2 in x, we get this step. Sine of this rest of the terms as it is, here x is pi by 2, here also x is pi by 2. Keep that all the terms as it is. Minus, now lower limit we have to put 0 in x, sine 0 we know 0, and so here also sine 0 is 0. Lower limit becomes 0. Now take next step, pi by 2 inside of this angle. We get this as it is, sine pi by 2 plus pi lambda by 2 upon this plus sine pi by 2 minus pi lambda by 2 upon 1 minus lambda. Okay, now here we have to use trigonometry formula, sine pi by 2 plus theta, sine pi by 2 minus theta. For that, consider this table and mug up this table. Okay, here in first column angles are there, theta, and these two are sine and cos trigonometry. And if you consider the intersection point of this column and this first row, you get cos theta, means formula is sine of theta is equal to this, means sine of pi by 2 minus theta is cos theta, sine of pi by 2 plus theta is again cos theta, cos of pi by 2 minus theta is sine theta, cos of pi by 2 plus theta is minus sine theta. Again same in this uh, um, compartment, sine of pi minus theta is sine theta, sine of pi plus theta is minus sine theta, cos of pi minus theta becomes cos theta, cos of pi plus theta becomes minus cos theta. Here again 2 pi minus theta and 2 pi plus theta. These are the formula for sine and cos, and these are the angles. Okay, just mug up this formula, mug up this table. And using this formula, this sine of pi by 2 plus theta and sine pi by 2 minus theta. Sine of pi by 2 plus theta is cos theta. Sine of pi by 2 minus theta is again same cos theta. Therefore, this step becomes cos of pi lambda by 2 plus cos of pi lambda by 2. Okay. You have to write here the reason sine of pi by 2 plus theta is equal to sine of pi by 2 minus theta is equal to cos theta. Both are same, you can write in this way. Okay. Now, in the numerator, cos pi lambda by 2 take common outside the bracket. 1 upon pi into this. Into bracket remains 1 upon 1 plus lambda plus 1 upon 1 minus lambda. Now, you have to solve, cross multiply. We get 1 minus lambda plus 1 plus lambda upon multiplication of these two. Now, lambda gets cancelled. 1 plus 1 become 2. A plus b into a minus b becomes a square minus b square. Formula. Okay. That's why answer is 2 cos pi lambda by 2 upon this pi into 1 minus lambda square denominator as it is. This is the value of a lambda. Put this value in our original answer, that is fx, Fourier cosine integral formula. Here we get fx is equal to 2 upon pi integration this a lambda as it is, only pi is there. Take 2 upon pi outside of the integration here itself, 0 to infinity cos pi lambda by 2 upon 1 minus lambda square. 2 upon pi outside of the integration cos lambda x d lambda. This is the Fourier cosine integral formula for the function. Now, similar way, Fourier sine integral formula is also calculated as using the formula in the same manner. That is, Fourier sine integral formula is given by fx is equal to, what is the difference between this formula? Just replace sine by cos or cos by sine and a lambda by b lambda. That is the only difference. Okay, fx is equal to integration 0 to infinity b lambda sine lambda x d lambda, call that equation number 2, where b lambda is 2 upon pi integration 0 to infinity fx sine lambda x dx. Okay, again we have to solve this as per this method. These are the steps. Okay, b lambda is equal to 2 upon pi cos x is the function value 0 to pi by 2 sin x sin lambda x dx. Here we want to use again sin a cos b formula. Okay, what is the sin a cos b formula? It is half sin a plus b plus sin a minus b. Okay, just Magam only one formula, whether it is sin a cos b or cos a sin b, because multiplication is a commutative term. Sin a into cos b is equal to cos a into sin b. You have to just make sure what is the a value here. Okay, a value is nothing but sine trigonometry's angle. Okay, that's why sin a cos b, what is a here? Lambda x. What is b here? X. Okay, according to that you have to use this formula. Therefore, put this value here, formula. 2 gets cancelled, 1 upon pi. Again, these are the same steps as earlier formula. You can go by this. Okay, I have solved this already. And final answer is this. Okay, go by the statistics or algebra here. The steps are same. Here also pi, cos of pi by 2 plus theta, cos of pi by 2 minus theta. We are using cos of pi by 2 plus theta is minus sine theta. Cos of pi by 2 minus theta is sine theta. These are the sum arithmetic. Okay, the final answer is this. Now again we have to resubstitute this value in our function. That is, from this equation number 2 is our original answer. Equation 2 becomes fx is equal to integration 0 to infinity 2 upon this is b lambda sine lambda x d lambda. Okay, take 2 upon pi. What is the constant? Whatever the variables or constants are there apart from lambda, except lambda everything is constant. That's why 2 upon pi take outside. Integration 0 to infinity this numerator into sine lambda x upon this denominator 1 minus lambda square into d lambda. This is the answer for our question. Okay, now let us move to next example. The fifth example. Okay, let us see now fifth example of the chapter. Prove that this integration 0 to infinity sin alpha pi alpha sin alpha theta upon 1 minus alpha square into d alpha is equal to, this is the function pi by 2 sin theta in 0 to pi, theta lies between 0 to pi, and for theta greater than pi it is 0. Okay, now if you observe this integration is with respect to alpha. Here alpha, pi is a constant, doesn't matter, and here also alpha, and except alpha theta is present in this trigonometry. That's why we have to use Fourier sine integral formula here. Okay, that is the only logic, or that is the only way you can identify which formula we can use. Now here for our convenience, see, in our examples, in our formulas, x is there, lambda is there. That's why in the function fx, x should be this is our function, and this is given in the form of theta. That's why we can, for our convenience, we can replace theta is equal to x. This is our first step. Write down this as a first. Replace theta is equal to x, that is a dummy variable, totally dummy variable. We can use for our convenience only, and at the end of the at the end of the example you can resubstitute x or theta. Okay, now for our convenience, replace theta is equal to x. Here doesn't it is contain only theta here, and this is our function. Replace theta is equal to x everywhere. Our original equation or original example becomes 0 to infinity sine pi alpha sine alpha x, okay, upon 1 minus alpha square d alpha is equal to pi by 2 sine x when x lies between 0 to pi, and it is 0 when x lies x greater than pi. Okay, this is our function. Now we are now which formula we are going to use? Fourier sine integral. That's why Fourier sine integral is given by the formula fx is equal to integration 0 to infinity b lambda sine lambda x d lambda. Call that equation number 1, where b lambda is 2 upon pi integration 0 to infinity fx sine lambda x dx. Okay, what is the fx function? This is our ff function. Now fx function is given in interval format. It is 0 to infinity. Okay, this is in between, pi is there, suppose pi is a positive. 0 to pi, function value is pi by 2 sine x. Okay, and in pi to infinity, but that is x greater than pi, function value is 0. That's why this integration 0 to infinity split into 2, where second integration is 0, you don't need to write 0 here. Only one integration is present here, 0 to pi, and value of function in 0 to pi is pi by 2 sine x, which is given in the example itself. That's why pi by 2 sine x sine lambda x dx as it is. Okay, now we have to solve this integration. Pi by 2 by pi gets cancelled. Integration 0 to pi sine x sine lambda x dx as it is. Now of course we have to use sine a sine b formula. What is sine into sine b? Sine a sine b. Remember, in mathematics everywhere you have to mug up all the formulas, all the basic formulas, whether it come from derivatives or integrations or such type of algebraic formulas. Okay, just there is only one way to mug up all the formulae. Just write down all the formulae repeatedly, 1 to 2 times you can write down. There are hardly 20 to 30 formulas throughout the M3. Okay, That's why just write down all the formulae, uh, one or two or more than two times repeatedly. You will automatically get remember all those formulas. Okay, it will take hardly 1 or 2 hours for that. Here sin a sin b formula is half, obviously, cos a minus b minus cos a plus b. You have to just reverse this formula of cos and middle sign minus. Okay, now what is a here? Sin a, that is a is x, b is lambda x. Okay, I put these values here. We get cos of a minus b minus cos of a plus b, half as it is outside of the integration. Take x common from the bracket here both side, and integration of cos is sine, here also sine, divide by angle derivative as it is. Okay, now put upper limit pi here in the x. We get this upper limit, rest of the terms as it is, minus bracket as it is, 0 in x. We get sine 0 sine 0 0, lower limit becomes 0. Now take pi inside. Okay, what we have then, those formulae, find sine of pi minus theta, sine of pi plus theta. We have already have this. Sine of pi minus theta is sine theta, sine of pi plus theta is minus sine theta. Write down as it is here. We get sine pi lambda minus minus plus sine pi lambda upon as it is. Now take sine pi lambda common from the denominator. We get sine pi lambda upon 2 into bracket 1 upon 1 minus lambda plus 1 upon 1 plus lambda. Now cross multiply, we get denominator LCM of this 2, 1 minus lambda into 1 plus lambda, 1 plus lambda plus 1 minus lambda. Lambda gets cancelled, 1 plus 1 becomes 2, that 2, this 2 gets cancelled. Answer becomes this b lambda is equal to sine pi lambda upon 1 minus lambda square. Now put this value of b lambda in our Fourier sine integral formula fx from 1. We get fx is equal to integration 0 to infinity this b lambda as it is sine lambda x d lambda. Okay, now there write down this integration on LHS side. Fx we have given already this for function which is given in the example itself, which is equal to pi by 2. Put the value of fx here, sin x 0 to pi, and it's 0 for x greater than pi. This is our answer what we have to prove. Okay, now we have just to make the difference here, make the we have used here dummy variable. That's why at this end of the example we have to resubstitute x equal to theta here everywhere. That's why it becomes here x is equal to theta, here x is equal to theta, and here also theta. Again, what is our, this is our original question. This is not needed actually. Again, okay, this if you compare this example with this example, only dummy variable is here alpha and here lambda. That's why I replace again lambda is equal to alpha to get our original question. Everywhere we get this answer. Okay, this is our term integration. Now consider the next example. Question is express the function fx is given. Function is given in the interval format 1 for 0 to pi, 0 for greater than pi means pi to infinity, as a Fourier sine integral, and hence evaluate this question. Okay, the question has two sub questions. First question, we have to find out Fourier sine integral of this function, and whatever the answer we are getting from that we have to evaluate, hence evaluate this integration. Okay, now let us see. First, Fourier sine integral straightforward question is given by fx is equal to integration 0 to infinity b lambda sine lambda x d lambda. Call that equation number 1, where b lambda is equal to 2 upon pi 0 to infinity fx sine lambda x dx. Okay. Now put the value of function. Our integration is 0 to infinity, but the function is given in the form of 0 to pi. Function is 1. Okay, and pi to infinity function value is 0. No need to write 0 integration. Integration become split into 2, 0 to pi to infinity. This integration becomes 0. This function value is 1. Okay, that's why integration of sine is minus cos lambda x upon lambda x integral derivative is lambda, limit 0 to pi. Therefore take minus 1 upon lambda outside, we get minus 2 upon pi lambda. Now put upper limit here. Whatever the constants or minus signs, take outside before putting the upper and lower limit. Here cos lambda x only consists of x, that is our variable of integration. That's why rest of the terms take common, and ultimately on that step only you can put the limits. Cos pi lambda minus cos 0 is 1. Okay, cos 0 is 1. You have to remember everything. Sin 0 is 0. Okay, that is the answer. Now for this minus and merge into inside, we get 2 into reverse this 1 minus pi lambda cos pi lambda upon pi lambda. Now put this value of b lambda in our original function. Fx is equal to integration 0 to infinity this term as it is into sine lambda x d lambda. Take 2 upon pi is a constant outside. Answer for our first question is fx is equal to 2 upon pi, this bracket sine lambda x upon lambda d lambda. Okay, now this is our first answer. Okay, now how to solve this using the earlier answer? If you observe this and this, what we want to do here, see, integration 0 to infinity is there, we get this 1 minus pi cos pi lambda is also there, upon lambda is also there, sine lambda x is also there, right? That's why this integration becomes this pi by, take 2 by pi on that side, we get integration 0 to infinity 1 minus cos pi lambda upon lambda sine lambda x dx, d lambda is equal to this pi by 2 into fx. Okay, now we have to find out the ultimate value of fx. For that, one formula is there, but fx is equal to f of x plus x positive x raised to plus f of x raised to minus. That means fx is nothing but the average value of the positive and negative values of function. Okay, f x positive left hand side limit, you have already studied that in limit theory. Left hand side limit and right hand side limit of the function divided by 2, that means average of that 2 is the original function value. What is x of f of x plus? These are the two intervals. Okay, 0 to infinity contains fx split into 2. First interval 0 to pi and second interval pi to infinity. Addition of these two functions divided by 2 becomes the original function's value. That's why f of x plus 1 plus 0 divided by 2. That means answer is 1 by 2 for the function. Now put this value of fx in here. We get integration 0 to this is infinity whole and LHS side is equal to pi by 2 into this half. That means pi by 4, which is what we required. Okay. Now here are some homeworks to you. That is, we have to find Fourier integral of function. Normal Fourier integral formula. Fx is given in the integral form e raised to ax, e raised to minus ax, x less than 0 and x greater than 0. For a less than greater than 0, a less than 0. Okay. This is not sine transform, this is not cosine transform, this is Fourier integral formula. Earlier first point of this chapter. Okay. Use this formula to find a Fourier integral function. you get the answer this. Just tally that answer. Okay. In the next lecture, we are going to see Fourier integral theorem and the examples depend on that theorem.